Okay, we're going to try question 10, but before we do, I gave a note to a special little note on a little piece of paper that had three ideas that I said could really help you in probability. If you just knew them, there'd be a question where you could get lots of marks. Well, let's just start it. If A and B are mutually exclusive events, then the probability of A or B, and that can be given with a symbol like this, the probability of A or B happening is just the probability of A plus the probability of B. And why is that? Because there is no intersection. So if it's mutually exclusive, remember that the intersection of A and B is 0. So if two events are mutually exclusive, they don't cross over. Their intersection, if you had a Venn diagram, those two circles wouldn't touch each other. That's the first one. The next one, I'm going to go down to this one. If they say the word independent, then the probability of A and B, and that's what this intersection here, if you want to find their intersection, it's just the probability of A times the probability of B. So that's the second one that's super important. But the addition rule you should always write down. It actually works for mutually exclusive or inclusive events, because if this is 0, you just end up with this statement here. But it always works. The probability of A or B, sometimes written with a little union thing, the probability of A union B is the probability of A plus the probability of B, but you subtract that intersection to get the right answer. If you know those three things, independent, you multiply the probabilities, mutually exclusive, there is no intersection. The intersection is 0, or for all events, you add A, the probability of A, probability of B, and subtract the intersection. If you know those three formulas, it's going to get a lot easier. Like, watch this. They give you the events A, B, and C. This is the question from the prelim. They give you the probability of A, B, and C, but they tell you some different things. A and B and C are independent. What does that mean? I can find their intersection, A intersection B, just by multiply them. A and C are mutually exclusive. What does it mean? Their intersection is 0. So the first question is, what's the intersection of A and C? Well, if it's mutually exclusive, it's 0. Pretty easy. That's all there is to it, because you learn mutually exclusive means this intersection is 0. What about the intersection of B and C? Well, we've got they're independent, so it's not 0. So, but because they're independent, we can take these probabilities and multiply them together and get 0.08, and that's your answer. There you go, the probability of B and C. Now the last question, the union, A union B, that's where you need to know this formula. The probability of A plus the probability of B minus the intersection of A and B. And if you've got that formula, it gets pretty easy. You put in A, you put in B, but then you go, I don't know the probability of A and B. Oh, but that's not hard. I just go 0.3 times 0.4 because they're independent. So you get 0.12. And then you go 0.3 plus 0.4 minus the 0.12, because you know this formula, you get 0.58. But I want to show you with a Venn diagram that you could have actually put this stuff in and really see why it's true. Well, where would you put 0.08? You'd put it where B and C cross over. I drew a diagram where A and C don't cross at all. They have no intersection. And that's right, A and C is 0. But 0.18 is where B and C. We did 0.12 is where B and A cross over. Hey, it looks like to make it add up to 0.3, that'd have to be 0.18. To make C add up to 0.2, that would have to be 0.12. And to make B add up to 0.4, there must be a 0.2 out here that's not crossing where B and C are. Look at all those numbers add up to 0.4. There's the Venn diagram for the whole thing. Now, how would you do A union B? Just add up everything you see in A and B. 0.18, 0.12, 0.2, and 0.08. add it all up, hey, you get the same answer. I kind of like to look at the Venn diagram to see exactly why all this works. Okay, so again, just going back to this thing, mutually exclusive means the intersection's 0. Independent means you can multiply the probabilities to get the intersection. And you've got to learn this formula and use it. They might give you P of A, P of B. They might give you 3 things and solve for one. In this one, we could figure out these 3 things and get our answer.